To example 6 from notes 5.1 day 2. Here we're asked to sketch the graph of f of x equals e to the x. And in the previous day's class, notes 5.1 day 1, we graphed exponential functions. So here we have an exponential function where the base is e. So we're going to go ahead and sketch this. We're going to try to determine a few points to sketch on our graph. So I'll make a little table here. X, and then we're going to have our y value, which is equal to e to the x. So we'll choose some convenient values for x. So let's try negative 1. That would give us e to the negative 1, which is 1 over e. And I said here we can use our calculator to get approximate values to plot, but not for graphing. So I'm going to bring over the calculator for a second. And we want to do e to the negative 1, so I can do e to the negative 1 and hit enter. The other way I can do this, determine this, I can do control divide, and then I can do 1 divided by, and then I can use e, which is on the pi button, and then go ahead and click enter. Either way, it's about 0.37. So 1 over e is about 0.37, and for the future, it'll be good to know a couple of these values in terms of e so that you could sketch graphs without your calculator. When x is 0, we're going to have e to the 0, which is 1. When x is 1, we're going to have e to the first, which is e. When x is 2, we're going to have e squared. E squared, I'll get that from my calculator again. So let me pull that over. E squared, so I'll do e to the x. E squared is 7.4. So, which is about 7.4 to help us graph. Okay, so let's sketch this graph. So negative 1, I've got 0.37. When x is negative 1. When x is 0, it's at 1. When x is 1, it's at e, which is 2.7. 1 to 2.7. When x is 2, we're way up at 7.4. So 5, 6, 7.4. And then we'll try to make a nice smooth curve going through these points. Let me fix this for a second because the graph does not go beneath the x-axis. It's a little hard to draw on the tablet. So this graph is going to have a horizontal asymptote at y equals 0. So it's going to get closer and closer to the x-axis but never touch it. Does this graph represent exponential growth or decay? Looking at it, we should be able to see that it's growth, but we also know that it's growth. All right, growth here, because when we think about y equals a times b to the x, our exponential function, we have growth if b is greater than 1. We have growth. And here, the base is e. So for this function, b is equal to e, which is about 2.7, which is greater than 1. So we definitely have growth. Here, the next two examples were asked to think about transformations. So if we have a new function, g of x, and it's equal to 1 plus e to the x, it might be easier for you to see the transformation if we think of this as e to the x plus 1. So when I have e to the x plus 1, what I'm doing is I'm adding 1 to y values, so this graph will be shifted up 1 relative to the parent function, which is e to the x. And the last part asks us what is the asymptote for the graph of this new function, 1 plus e to the x. If it's shifted up 1, it's also going to shift up that horizontal asymptote. So the horizontal asymptote on e to the x is y equals 0. So when we have the horizontal asymptote for our new graph, the horizontal asymptote for g of x, which is equal to 1 plus e to the x, is y equals 1 because this is shifted up 1, which will also shift that horizontal asymptote up 1.